All right, this is chapter 1.6, modeling with linear functions. This is the core vocabulary. We'll start with a line of best fit. And a line of best fit is a line that lies as close as possible to all the data points in a scatter plot. So here we go. It's a line that lies as close as possible to all points on a scatter plot. Right? And sometimes we'll end up freehanding these things. Sometimes we'll actually calculate pieces of it, things along those lines. So if this is an XY, and you have a whole bunch of dots that are like this, notice how they all kind of congregate in one area. A line of best fit would probably be somewhere right in there. Now, obviously it does not hit all the points, but it is the closest approximation to a line that it can be. Now, obviously, that example I just showed you is not perfect, but it gives you an idea of what we're looking for. We're looking for a line that hits as many of the data points as humanly possible. Okay. A correlation coefficient is has to do with the line of best fit, and the correlation coefficient is a number R, a number R. It's called R, and it is from -1 to +1. That tells how closely the data, not the data, the equation, fits the data. Okay? And so here's what we mean by that, is basically how close do the data points, so if I go back to the early example, how closely do all these little points fit the line that we created? How close do they fit that line that we created? And they range from -1 to +1. It's on a Likert scale, so don't worry about the term Likert scale. So if I go from -1, 0, +1. Well, let me write these a little different. If R equals -1, R equals 0, and R equals 1, -1 and +1 are as strong as you can possibly get. All right, strong as you can possibly get. I mean, obviously, the -1 is in the negative direction, has a negative slope, so that would be a line that looks like this, goes up and to the left. The +1 would be a line that goes like that. It's got a positive slope to it. All right, and to be on the ones, these are perfect. All right, if you are -1 or +1, you are perfect. So this one is perfect negative correlation. This one is perfect positive correlation. Okay? 0 is no correlation whatsoever. All right. There's no correlation whatsoever. It means the line and the data points essentially have nothing to do with each other. And just to kind of give you some ranges, in general, if we are less than 0.85, so if we're in this region, we're going to say it has strong negative. That's strong negative correlation. Now you might say 0.82. I mean, it's a bit speculative, but just for giving an idea, if you're less than 0.85, negative 0.85, or if you're bigger than positive 0.85, you're in this range. I would consider those ranges to be strong negative or strong positive. Positive. Strong negative or strong positive correlation. Okay? If you are between, let's say, 0.2, negative 0.2, and positive 0.2, we're just going to go ahead and say this is none. So if you get a correlation of like 0.13, it's like right there. All right, we're going to call that no correlation. And we're going to call these over here weak. So this is weak. That's weak negative correlation. And this is weak positive correlation. Okay? So now that I've completely confused the heck out of you with that looking graph. All right, so just to recap, if I go from left to right, -1, right there, that is perfect negative correlation. Every dot is right on the line and has a negative slope. Okay? If I am in this region, I would say I'm not necessarily on that line, but it's a negative slope. It is really close. We're going to call that a strong negative correlation. It's a good line. Okay? This one, yeah, it's negative correlation, but it's weak. It's not the best approximation of what's going on, but if you really want to use it, go for it. All right? The middle section, we're going to go ahead and say none. 0 is perfectly none. But in that middle section, we're going to say it's not. There's no correlation. You really can't say anything. You might even extend that to 0.3 on either side, but we'll just go with 0.2 for the time being. Right here, this would be weak positive. It has a positive slope, but the dots are related to the line, but it's not the best approximation. It's not that great of data, not that great of what's going on. If you're above 0.85, we're going to say that's strong. It's a good line. It's a good measurement. Very few things are perfect, but we're going to go with it. It's a good, strong one. And if you're on 1, it is perfect. The dots are directly on the line. They are perfectly on that line that has a positive slope. All right? There you go.